So we've already understood how we can find and calculate the area under the curve and the axes. This time we're going to be finding how we can calculate the volume of rotation or the volume of revolution. So what is a volume of rotation or a volume of revolution? So let's take this curve for example. You have a curve over here and you have some area under this curve. Now you're going to be asked to find the volume of revolution when this area is rotated 360 degrees about the x-axis. And what that means is basically when you rotate this area 360 degrees about the x-axis, you're basically going to get a shape that looks something like this. And then you're going to have your x-axis running through this shape kind of like that. So you're going to get a 3D shape and you're supposed to find the volume of this. And in the same way, if you look at this diagram right over here, you have this red area. If you go ahead and you rotate it 360 degrees about the y-axis, you're basically going to get a shape that looks something like this. And then the y-axis is basically going to be passing through this shape. So the good thing is they're not going to be asking you about what the shape looks like, but you're just going to have to find the volume of whatever the shape is going to be. And so you just need to learn this formula right over here. And if you know this, you can find the volume of revolution for any area or any shape. So let's say I go ahead and I do it for this curve right over here. So I have some area and I'm supposed to rotate this 360 degrees about the x-axis. So I know my formula. I know that my formula is basically equal to this thing. So it's an integral, a box up there, some brackets over here. Then I'm going to have a square and then a d, the box. Okay, now how do you fill up the boxes and this empty space right here? That's the tricky part. So you know that you're supposed to rotate this area about the x-axis. So you're going to go ahead and you're going to put an x over here. So that's your first box filled. Now you need to know your bounds, so your limits, and your limits are basically 0 to 5, which you can clearly see. So that is going to be 0 to 5. And then you're going to write the equation. Now, since you're rotating the area about the x-axis, you basically need the equation in terms of x. Or in other words, y has to be the subject. When y is the subject, you're going to get the equation in terms of x. Now, luckily, it's already in terms of x, so we're just going to add an x squared over here. And then you can just go ahead and solve this using your integration techniques. In the same way, if we look at this diagram, then we have some area over here and we're supposed to rotate it 360 degrees about the y-axis to find the volume of revolution or volume of rotation. So you first go ahead and write your formula. That's going to look something like this. And then you're going to have an empty space over here, a square, don't forget that square, and then this thing right over here. So this time, since you're trying to find the area, the volume around the y-axis, you go ahead and you put a y over here. And then your bounds are basically going to be 0 to 3. And then this time you need your equation in terms of y, because you're rotating your area around the y-axis. So you have this thing, you get it in terms of y. How do you do that? Well, you just make x the subject. So that's just going to be x is equal to square root y. Just go and put this thing in here. And then you can solve this out using your integration techniques. So you basically just need to remember this formula up here. If you remember this formula, you can basically go ahead and find the volume of revolution. At times when you're going to create your integrals in this form, it's going to be a little tricky to solve these out. And that's mainly because this 2 over here is going to play a role. So I'm just going to show you guys how this 2 is going to work out. So we have this first example over here, and let's say you're trying to solve this integral to find out the volume of rotation. Now, how is this going to work? Well, you can clearly see a square root over there, and you can see a 2 over there. So what you can do is you can clearly just cancel those 2 out. And what that is going to do is basically that is going to free this, and that's going to free this. And then, of course, then you can split the integral into 2 parts, and then apply this sort of this form x raised to the power n. you know it integrates to xn plus 1 and n plus 1. So that's a plan, and that's what I'm going to do. So if I cancel out the square root with a square, I'm basically going to be left with this thing plus this thing dx. Now I can split the integral into two. So this is going to be 5, 6 x to the power 4 dx plus 5, 6 x squared dx. And then I can solve this out. So looking at the second integral right over here, you can see that this is a little tricky because it has there's a power of -1 in there. Now the problem with this is that you cannot solve -1 powers, right? This form or this form both of these forms do not work on power -1. Okay, if you have a power of -1, both of these forms are not going to work. So what do you do with this? Well, you're trying to think about this, and basically what you can realize is that over here you can actually consider this entire thing as A, and you can consider this entire thing as B. And what you can realize is, since obviously these two things are different, this has a -1 power over it, this only has a +1 power over it. So you can actually consider this thing A, and you can consider this thing B. And so it's basically, in other words, this is basically A plus B whole squared, right? And so you can solve it out that way. So what you can do is you can actually have this thing turn out into A plus B whole square turns into A square plus B square plus 2AB. And this is going to be x plus 3 minus 1, and then it's going to have a power on it, and then it's going to be plus x plus 3, then it's going to have a power on it, and then it's going to be 2a, which is x plus 3 minus 1 times x plus 3 positive 1, and then it's going to have a dx. This entire thing is going to turn out to be 1. Why? Because you can see this is x plus 3 right over here. This is x plus 3. It's raised to the power -1. This is x plus 3. It's raised to the power 1. So the bases are same. This right here is the base. That right there is the base. The bases are same. Both of those things are being multiplied, and they have powers that have opposite signs. So it's negative over here. It's positive over there. So when you have, let's say you have 2 minus 1 multiplied by 2 plus 1, that basically turns into 2 to the power 0, and that just turns into 1. Anything to the power 0 is 1. So that entire thing is going to turn into 1, and so 1 multiplied by this 2 is just going to be 2. So you can actually erase all of that, and you can basically just simplify this to this thing right over here, and then you can actually take the square of this thing, and you can take the square of this thing. And now what you can do is you can split this thing. You can see that this thing is basically in the form of ax plus b to the power n, and n is not -1 anymore. And then this thing is also in the form ax plus b raised to the power n, and this thing is going to be x raised to the power n. Now over here, x is to the power 0, so remember that where there's no x, the x is to the power 0, and so you can solve that using this form, solve these using these forms. And so you can split this integral into 3 parts. That's going to be this part, and this part, and then you can apply this, and this over here. Okay, so going on to the last part, how are we going to solve this? Now you may just do this. You may do this. You may take the y into the numerator, and so that would be y minus 2. And then it's going to be -2 raised to the power 2 dx. My bad, this is not dx, this is actually dy. This is obviously going to be dy. You may just do that, and then what you may do is you may just be like, oh, well, look, that is basically in the form ay plus b raised to the power n, and so I can integrate it. But be careful, because remember, this form or this form, the x has a power of 1. You can clearly see this is not 1, this is -2. So you cannot solve it out right now. You cannot apply this form on this. So what you can do is you are again going to apply you can say this thing is a, this thing right here is b, and so it's basically a minus b whole squared. And so you're just going to apply this identity, which is going to be a squared minus b squared minus 2ab, and then you're going to solve it out. And then you're going to get this form. Then you can basically split the integral and then solve it out. So you got to be a little careful about these 2's, especially when you're doing these volume questions, because they'll try and give you these tricky problems where you'll have to kind of think about what you got to do with these 2's over here.